this video, we're going to walk through how I would use Synapse to process a report. We'll pretend that we're back in December 2020 and Mandiant, FireEye at the time, just released a blog describing a supply chain compromise that they uncovered. As an analyst, it's my job to figure out what exactly they're talking about, if this is activity that I might be familiar with, if it aligns with anything that I've been looking at, or if it's entirely new to me. I also want to be able to take the indicators that they provided and try and build those out, see if I can identify additional indicators of compromise and just increase my visibility into the set of activity that they're describing. At the end of my investigation, I'll also want to be able to put together a report summarizing my findings. I can share that with my leadership, and they'll hopefully use that to help inform some decisions that they make regarding what this might mean for our company or what this might mean for our clients if we have clients that we're responsible for protecting. So this is the blog that I'll be working with. And from here, we can go into my Synapse instance. And the first thing that I'm going to do is fork a view. Forking a view is going to give me an analytic scratch space in which I can do my work. I'll still have visibility into all of the data and the annotations from our previous research and analysis projects. However, during the course of this investigation, all of the data that I add and the annotations that I make are all going to be contained within my forked view. This means that when I'm done with my investigation, I can go through and review all those changes. I can correct any errors that I may have made, and then I can merge that data down into our underlying production level. So I'll name this MB-OSINT, and I'll go ahead and create this forked view. So right now I can see that I've created that forked view and I'm in my scratch space. At this point, I want to be able to bring that blog into my Synapse instance. There's a lot of different ways that I can do that. Because I have just that one blog and I want to do a careful read of it, I'm going to be using a tool that we have called the Spotlight tool. And what Spotlight will allow me to do is it will allow me to download the blog. It'll represent it on the side here. It will also model it as a media news node. And then it will go through and it will scrape out indicators that it recognizes from the text. And those will appear on this side here. Because we already pre-processed this blog, just for the sake of the demo and the sake of time, you'll also see additional things that I might go through and include that I would like to reflect as well. The things that Spotlight will scrape out for me include those really basic tactical indicators. So these are things like different hash values, email addresses, IP addresses, FQDNs, URLs, things like that. So typically what I'll do as I go through is I'll first model the properties for that media news node so that I can recognize it a little bit more easily as relating to this blog. So I can go ahead and set the title property. I can also go maybe grab this first bullet point and set that as the summary, so I know what this blog is about. And then I'll also grab FireEye, since that was the name of the company, and set that as the publisher name. From here, I can go and start reading through the blog, and if there's any additional pieces of information that I would like to be able to pull out and model, I can go ahead and add that. For example, they refer to UNC2452 as the name of the cluster of activity that they're tracking. So I can go ahead and create that as an OU name, and that will appear here, and it's linked back to the media news node, so I know where that came from. As I go through, if there's anything else like this sunburst malware, I can reflect that as well, capture that as a node, it will be linked back. I might also run into some of the nodes that Spotlight has gone and pulled out for me. For example, this INET URL node. And in addition to capturing additional information and verifying the things that Spotlight has pulled out, I can also apply some tags. We use tags for a couple different reasons within Synapse. For example, we use them as a way to keep track of assessments, whether it's our own internal Vertex assessments or third-party assessments. While I'm working on this blog, I'll be using a lot of rep tags. So something that is reported by FireEye as UNC2452 will get a rep FireEye UNC2452. Or reported by FireEye as associated with that sunburst malware family, we'll get a rep FireEye sunburst tag. I'll also be using tags as a way to keep track of the data that I'm working with. So for example, for this specific project, I'll be using a tag VTX story Nightwatch, just as a way to keep track of all of the data that I'm working with that relates to this set of activity. This gives me an easy way to go and lift that data later if I need to. One of the things that I might see as I'm going through is data that I'm re-encountering or data that's kind of percolating up from the underlying production view, where we have all of the information from our previous research and analysis projects. So as an example, taking a look at this URL, I can see the details of this node on the side, and I can see the tags at the bottom. I have the tags that I might apply, these rep FireEye tags, but I also see a rep Palo Alto SolarStorm tag. This could be a hint to me that I'm re-encountering this data. Maybe this is a URL that one of my colleagues created previously. Maybe she was taking a look at some Palo Alto reporting, noted that Palo Alto said that this URL was associated with what they call SolarStorm, and applied that tag. So as I go through doing my work here, I re-encounter that data and I'm able to see that there's that context that we previously captured, and it can help inform what I'm looking at. So as I go through, I'll verify the indicators that Spotlight has scraped out for me. I'll add additional pieces of information, model those as nodes. Everything will be linked back to the media news node. I'll apply tags to keep track of FireEye's assessments, and I'll apply my VTech Story NetWatch tag just to keep track of all of my data. And when I finished reading the blog, I can go and lift that media news node in the research tool, and I can see that media news node representing the blog here. Everything we pulled in is linked back to this. Now, Spotlight is very helpful at going through the blog itself and going through that text. However, one of the things that FireEye had linked to was a GitHub page where they had additional indicators, and I'll want to fill those in as well. So we can go and take a look at that GitHub page, and they include two different CSV files, one with hashes and another with network-based indicators. And so to pull these in, I'm going to be using a tool that we have called the Ingest tool. And the Ingest tool is particularly helpful for one-time ingest of structured data. So CSV files are perfect, JSON, JSON-L files. What it will do is it will show me the contents of the file. This is the hashes CSV. And then down here, I have my Storm script. Storm is the query language that we use within Synapse. And I'm using my Storm script here just to tell Synapse how I'd like this data to be modeled and tagged. So in this example, I'm going to be creating some file bytes nodes and also some hash nodes to represent the data that's here. I'm also going to be applying some tags, a rep FireEye 2020-12-13 tag to note that this was data reported by FireEye on that date, and my VTech Story NightWatch tag to note that this is part of my overarching investigation. And finally, I'm going to be linking that back to the media news node representing the blog, so I know where this data came from. So I can go ahead and run that ingest, and then I'll do the same thing with that network-based indicator CSV. Here I can see the contents, and down here I have my Storm script where I'll be creating INET DNS CNAME records and INET DNSA records. I'll also be applying my tags, my rep FireEye tag and my VTX Story NightWatch tag, and then linking everything back to that media news node. So now everything is modeled, tagged, and linked back to our media news node. And at this point, I can see our media news node, and I can go and explore out and see all that linked data. And I can use scroll to form as a way to get an overview of all the different types of information that we were able to capture and link back. Now, typically at this point, after we've gone in and brought in all of the indicators that FireEye has released, I'll typically want to go and query those indicators against any data resources I have to see if there's additional information that's relevant that I can model and represent. How I would do that with Synapse is through tools that we have called power-ups. Power-ups are both connectors to external data resources and ways to extend the functionality of Synapse. So for example, the power-ups that we have installed on this specific Synapse instance include things like Synapse Alien Vault, Synapse Census, Shodan, Virus Total, Hybrid Analysis, all these different data resources. Power-ups are typically for resources that I would be querying again and again. For example, I'll not only query Virus Total for this specific investigation, but probably for every other investigation I do. The great thing about power-ups is that it not only allows me to easily query for information, but it will also model the results back for me so that I don't have to worry about that modeling. There's a lot of different ways that I can call these power-ups. In this case, because I was working with a lot of indicators at once, everything that FireEye reported, I actually took advantage of some automation to make sure that I was able to run those enrichment queries and represent that data in an efficient and timely manner. We support two different types of automation. There's cron jobs, those are the scheduled jobs, and then we also have triggers, which are event-based. I used a trigger to do my enrichment in this scenario, and my trigger is down here. It's named Enrich. And so how this one works is that every time I applied a rep tag and I said that this was reported by FireEye, it would launch this trigger, which would run a macro. It's just a container of Storm code. And the macro is called Enrich. We can actually see the macro if we go over to our Storm editor in the side here. Lift that. So this is the macro that would run. And what the macro is doing is it's going to identify the type of information that I'm feeding to it, and then pipe it against all the different power-up commands that are capable of providing additional information about that type of indicator. So for example, if I have an INET IPv4 address, it will go and query MaxMind, Alien Vault, Census, Shodan, NetTools, Zetalytics, and Virus Total. For additional information. Any of those results, it will bring back and it will model for me, which means that when I am taking a look at my indicators that I've brought in and I've modeled, if I would like to go and see what other information we might have about this FQDN, for example, I can just go and explore out and instantly be able to get all of that data that was brought back in from those enrichment power-ups that I ran. At this point, I might be a little bit more selective in how I run power-ups. So for example, if I'm taking a look at the DNSA records, maybe I notice one that maybe it overlaps with the same time period as this activity, and I'm interested to see if there's any overlapping infrastructure that was also hosted in this IP address. I can always go and pivot, take a look at that IP, and from here, I might go and manually query some of those power-ups. So for example, I can go and see what MaxMind can tell us about this. It gives us some geolocation information. Alien Vault has passive DNS data. I can see that made some changes up here, but let's check virus total for passive DNS as well before we pivot. So I can run some of those power-ups, and then I can go pivot to see what the results are that we brought back in and kind of work my way down that rabbit hole. I can also use the breadcrumbs feature when I'm done to kind of get back to my original starting point so that I'm not pivoting and then lost in the data. Some of the power-ups that we have will also include an accompanying workflow, which provides another way to interact with that power-up and that data resource. So as an example, one of the power-ups that we have is a Vertex threat intel power-up. We also have an accompanying power-up, or accompanying workflow rather, which we can see here. This workflow is not only helpful for being able to get a good high-level sense of what we know about threat clusters, threat groups, certain TTPs, activity, targeting, malware families, things like that. But it also will help me if I'm trying to capture that information. It'll help me walk through the modeling so that I can capture that information correctly. So just to give an example of what this data might look like, let's take a look at UNC2452. So if I wanted to know everything that we have in here based on FireEye's reporting of UNC2452, I can go ahead and look up that threat cluster. You can see that the reporter is FireEye. FireEye later said that UNC2452 aligns with what they refer to as AP29. I can see the tag, so any related nodes should have that tag on it. And then I can go and check out some of the different tabs here to see additional information. For example, there's 3 different malware families that FireEye said that are associated with this cluster, different techniques that FireEye has reported as well. If there are vulnerabilities, I'd be able to see them here. More media mentions, targeting information, activity like compromises, campaigns, things like that. Those are all different things that I'm able to use the threat intel workflow to not only capture, but also go and review if it's a cluster or something that I'm unfamiliar with and I need a high-level overview. If I'm ever curious about how many changes have been taking place within my Synapse instance, I can go and take a look at the metrics tool as a way to get an overview of that. So for example, right now the metrics tool is showing all of the changes that have taken place in my current view, so my scratch space, within the last hour. I can also go and see the changes for the entire cortex and change it to maybe the last week or so and get a breakdown of what those changes are. It'll show me the different users who have made those changes and the type of changes that have taken place. So I have a sense of what's been going on. Going back to our original use case and our indicators from that blog, everything that we've been looking at so far in this view has been displayed through tabular mode. However, depending on the type of information I'm working with, the type of analysis I'm doing, or even my own preferences as an analyst, it might make sense for me to display this information a little bit differently. And for that, I can take advantage of several different kinds of visualization modes that we have. So in addition to tabular mode, we also have a force graph mode. And force graph mode is particularly helpful as a way to see how nodes are or are not connected within the graph. So as an example, let's lift all of the nodes that are tagged with rep FireEye 2020-12-13. So everything that came in through the blog and through the GitHub CSVs. And when we lift these, what jumps out at me is that there's several clusters of nodes where we can see that the nodes are connected. But there's also a lot of nodes that are just kind of floating out by themselves, like this registry key and this file base that are not connected to anything. If we remember what this looks like and we go and lift a different query, So if we lift everything that we've tagged with VTX Story Night Watch, so this includes data that we brought in through enrichment and pivoting that we determined to be relevant to this set of activity. If we go and we lift this, the visual is different. We were able to, through that additional enrichment and research, we were able to connect all that information and be able to uncover a lot of the evidence supporting FireEye's assessment that this was all the same set of activity. It's all cohesive, it's all related to each other. We were able to identify all that and reflect it within our graph. Force graph is a helpful way to be able to see those connections that would be more difficult if we were in, say, tabular mode. We also have some additional visualization modes that you can take advantage of. For example, if I wanted to have a statistical breakdown of a certain set of data, I can always use stats mode. For this, we'll take a look at all of the file bytes nodes that we have within this cortex that FireEye has reported as associated with APT1, and we're specifically interested in those that have compile time data. Now, stats mode will take the results of this query and display it in different statistical projections for me. One of them that is particularly interesting is this over here, where I can see the breakdown by days of the week. It shows that it looks like the vast majority of these file bytes nodes were compiled Monday through Friday. There's a little bit of activity on the weekends, but not nearly as much. This might suggest that this was more of a organized, regular, concerted effort rather than someone just compiling malware as a hobby in whatever free time that they had. I can always take this breakdown and change it from days of the week to see hours of the day. And the peaks and valleys here might give some suggestion of when people are breaking for lunch or for dinner. The times where there's less activity might align with the time that someone is sleeping. So what I could do is I could always take what we had seen from the breakdown over days of the week and what we see from this breakdown over hours of the day and try to identify a time zone in the world where this would align with more of a 9 to 5 regular workday schedule. And that might be some additional evidence supporting my assessments of where these operators or these developers may have been based. I can also take a look at the compile times broken down over a longer time frame. For example, this is broken down by week, but I can go and change it to month, or I can also go and change it to the breakdown by year. It looks like we have one file bytes node that at least has a compile time of 2004. The vast majority of the samples that we have compile times from 2009 through 2012. Looks like we have 2 samples with 2013 compile times, and then that's the end of the data that we have for this data set. So stats mode can be a helpful way to break down your results into these different statistical projections. If we ever have any sort of geospatial information that we're working with, we can portray that in geospatial mode. This data that we're looking at here is actually from a research project that one of my colleagues had done where he was tracking a Russian cargo ship that the US had sanctioned back in 2014. He was able to map out the trip that this ship took, where it had gone to a Russian terminal. It then traveled south, seemed to go towards Cyprus before turning off its AIS beaconing information. So we were no longer able to identify where this ship was. When it reappeared back online, it went back north. One of the pieces of information that was particularly interesting that we were able to get from this data provider was the draft of the ship, which is where the ship is sitting in the water, how high or how low. And my colleague found that when the ship was leaving the Russian terminal, it was sitting much lower in the water, suggesting that it contained cargo. It was heavy. However, when it was reappeared back on the location data and was traveling back north, it was sitting much higher in the water, suggesting that it was had delivered that cargo and was now no longer carrying anything. My colleague assessed based on the data that he had that this ship may have been turning off the AIS beaconing as a way to hide where it was going into port and delivering this cargo. His assessment that was likely going to Cyprus, and that turning off the AIS was kind of a way to give itself some plausible deniability about who it was delivering to and where it was delivering. Now, all of these different visualization modes are things that we're able to export. So going back to our original example of that solar wind supply chain compromise, if I'm doing my research and I would like to put together my findings in a report, I'm able to export those to what we have called stories, which is the native reporting tool within Synapse. And I can put together a story for my leadership that includes images. It can include markdown text as well to explain some of my findings. And then it can include data directly from Synapse. This is information that's in tabular mode. However, I can also include information from stats mode that's in a statistical projection there, from force graph, or also from geospatial if I'd like. What is most helpful for me about having stories embedded within Synapse is that's very easy to go and create or input your data and then be able to update it or change it if need be. For example, these domains that I have here, if I'm continuing to kind of finalize my research or as I'm putting together my report, and I would like to make sure that my findings that are displayed here are as up to date as possible and they accurately represent the data that I'm looking at in the research tool, I can always go to the menu on the side here and refresh the query that I'd use to pull these nodes, or even refresh the nodes themselves if I'm concerned that maybe a property has changed. And since this is embedded within Synapse, it will automatically update, show the current data. Just like everything else within Synapse, Stories is also designed to be collaborative. So if I'd like to have a colleague come in and check my work before delivering this report, I can always share the story with her. She can come in if she has questions about this data, maybe where I got it, or she just wants to do her due diligence. She can always copy the query that I'd used to pull it, and then go and run that query in the research tool, query power-ups to pull in additional data, pivot, things like that to check my work. Stories also includes a comment component, so someone can leave me notes. I can also reply back. And then when I'm ready to deliver it, I can deliver this either internally by giving someone viewer permissions, or I can also go and export this as a PDF so that there is an external to Synapse copy that I can then go and deliver. So at this point, I've pulled in the blog itself. I did a close read through Spotlight, which helped me with some of the modeling. I applied tags. I used the ingest tool as a way to pull in that additional structured data on those two CSVs. Modeled everything back to the media news node representing the blog itself. We used some automation. We took advantage of that trigger to query all those power-ups, brought back additional information from all those data sources, modeled it for us. We were able to pivot around, view our data in different ways through the different visualization modes. And then I was able to put together a report summarizing my findings. At this point, I'm done with my investigation. I'm still within my porked view, so I can always take a look at the changes that I've made, just a final check to make sure that there's nothing that I need to fix or no errors. And then I can go ahead and merge this down so that we'll join the rest of the data that we have in our production level view.